going to do a few examples of solving some problems related to zero launch angle. As always, I recommend that you read through the problem, pause it, write down what you know, and see if you can figure out what you need to do in order to calculate the answer to the problem. So, say I kick a soccer ball horizontally off a cliff. It's 15 meters high, and it's 12 meters from the base of the cliff. It can be helpful to draw a picture sometimes. So we've got our cliff. It's 15 meters high. I'm up here. Kick the soccer ball. Goes off horizontally. Curves down, and it lands 12 meters away. Drawing not to scale. Okay, so this makes it pretty clear. If you look at your picture, we know that delta x is 12 meters, delta y, again, is tricky, but if we're calling down negative, remember that our delta y is going to be negative 15 meters because we wind up at height of 0. We started at the height of 15, 0 minus 15. So if we want to find initial speed, well, we also know, since the soccer ball was kicked horizontally, we know v naught y is 0. So our initial speed is just the x component. So to find the initial speed, we look to the x equation. But we run into the problem here that we know delta x, but we don't know v naught or time. So we're going to need to go over to our y equation to find time, and then plug it into the x equation. If we look at this, we know all the things we need to know. Delta y is negative 15 minus 1/2 g is 9.8 t squared. So go to our calculator, negative 15 times 2 divided by 9.8 square rooted. Error, non-real answer. What did I do? Negative 15 times negative 2. There we go. Divided by 9.8. Two negatives that go away. And take the square root, and we get that the time is 1.749, etc. And we should use that stored value. Take that, plug it into our x equation. We know our delta x is 12. Our initial speed is what we're trying to find, and our time is that stored value. So I just take 12 divided by answer, and I get that our initial speed, when I round it to sig figs, is 6.9 meters per second. All right. So we've got our initial speed. Now, what was its velocity as it hit the ground? Okay. Well, this is tricky. I'm going to store this value as v. But velocity, remember, is a vector. And now this soccer ball, starts out moving horizontally, but then gravity accelerates it downward. When it hits the ground, it's going to be moving at some angle. It will be moving downward, but it'll still be moving to the right. So we are going to need to do vector stuff to figure out the magnitude and direction of this velocity. So we want to find v final. Okay, well, what do we know? We know in the x direction, the acceleration is 0, which means that the x component of our velocity is constant. So if the x component of our velocity was initially 6.9, then we know the final velocity in the x direction is 6.9, and we should use the stored value at 6.85 something. I stored it in my calculator. Now that that's the x component of our final velocity, so actually I'm going to store it as x. Okay, well, in the y direction, then we need the final velocity in the y direction as well in order to find the magnitude and direction. Well, what do we know? We know delta y, we know v naught y, we know acceleration in the y direction, and we want to find the final y. Which equation has these four variables? That would be the time-independent equation. and we can plug our numbers in and calculate what that's going to be. So 2, acceleration is 9.8 downward, delta y is negative 15, v final y squared, we don't know what v final y is, v naught y, we know, is 0 because it was kicked horizontally. Right? Now this is where it's important to keep your components separate, because you might, if you weren't thinking about it, you might go, okay, 9.8, negative 15, v final, v naught. What's v naught? Oh, well, v naught is what we calculated in part A, and you might think, I need to plug in 6.9, but keep in mind, this is in the x direction, this equation is in the y direction, and those need to stay separate when you're doing your calculations. So you got this, plunge it in, 2 times 9.8 times 15, the negatives cancel out, 294, common mistake, forgetting to square root, that's equal to v final y squared, and when you have something squared, that means the result, we had v final squared equals 294, which means that v final could be plus or minus 17.14. Now, using our brains, we know that we called up the positive direction and down the negative direction. So when our ball hits the ground, it's not going up. That doesn't make sense. If it was going up, it wouldn't hit the ground. So we know that this must be the negative 17.14, which doesn't have any impact on our calculations, except that it will tell us, okay, our x velocity is positive, y velocity is negative, so when we get an angle, that's going to be an angle below the horizontal. So our velocity vector, 6.85, negative 17.14, is going to look like this. This is our final velocity vector. So when we find this angle, that will be below the horizontal. Now we have our two components. I will store this as y. And since I have my x component stored as x, my y component stored as y, to find the magnitude, I just take the square root of x squared plus y squared. And I get that's 18.467 sig figs. We should have 2 sig figs, so that's about 18 meters per second at our angle is inverse tangent of y over x. So that's 68.1, about 68 degrees. And then based on where our vector is, we can see that that's in the horizontal direction and down. So that is 68 degrees below the horizontal. Getting final velocity is probably the trickiest calculation we'll do with projectiles. Although when we do things like part A, there are 2 calculations we have to go through. It's just a 2-component calculation. So those are the trickiest calculations we'll do. Here's just another example of a problem we can solve. Tennis ball is thrown horizontally with initial speed, 5.7 meters per second. It lands a horizontal distance, 4.1 meters away. From what height was it thrown? Same sort of problem, but we're given different variables. Our initial speed is 5.7, and since that is horizontal, that means the x component of our initial velocity is 5.7 meters per second. We know that the y component of our initial velocity is 0 because it was thrown horizontally. We always know the x component of our acceleration is 0. And the y component of our acceleration is 9.8 meters per second squared downward, and I'm calling down negative. And we know that our projectile lands a horizontal distance 4.1 meters away. I want to know from what height it was thrown. Okay, well, in the y direction, we only have 2 pieces of information. We need to get a third before we can figure out what that height was. So we need to look to our x equation. What's the thing that always bridges the gap between x and y? It's always time. Our only equation in the x direction, delta x equals v naught t. Delta looks like an A. And we have v naught and delta x, so we can plug those values in. 5.7 times time equals 4.1. to find the time is 4.1 over 5.7, which is 0.71 something. And now that we have time, V naught A, we can look to our y equation. We can look to the time-dependent equation in the y direction. That's what we have the information for, which is just delta y equals 1/2 minus 1/2 gt squared. So delta y is minus 1/2 9.8 times time squared. So on my calculator, I'll square that value times 9.8 times 0.5. So my change in height, I didn't punch in the negative, it's negative 2.535. So from what height was it thrown? Well, that's just from 2.5 meters off the, I guess I didn't specify, the ground, the floor, the whatever it was.